one side, if it is divided into 5 parts, it doesn't mean directly that we can say that it is 1/5 of the whole area. But here, why it works? Because here, when I will divide this like this, think that you have five different how to say, angles. And here, when I will draw the height from this one, this height is for all of them. This height is for the triangle, this first triangle. This height is for the second triangle. This height is for the third one, for the fourth one, and for the fifth one. For all these 5 small triangles is the same height. Yes? And all the bases are same. Here, if it is A, also this one is A, also this one is A, also this one is A, and this one is A. If one of the area it's S, let's say, then S is equal to H times A over 2. And how many, and for the triangle, the second triangle, it's again H times A over 2. For the third one is H times A over 2. For the fourth one, so here the area of ABC is equal to 5S. So S is equal to area of ABC over 5. Because we have the common height and the same basis, this one directly we are dividing into 5. Okay? Are we clear with it?
Yes.
For A, if we'll come to A, here as you can see, DB is given, and here it's given that the angle BCD and the angle DCA, they are the same. Yes? Now,
Yes.
I will draw a height from D. We are looking for the area of ADC. Yes, ADC. We are looking for the area of ADC, this part. So if I know one side of it, and if I'm drawing a height from...
I'm sorry for being late, teacher.
No problem. I'm drawing a height from D to AC. Now here, can I say directly that, let's say this one, A, B, C, D, E. Let's say that this one is E. The DE is same as DB. What do you think? Can I say this? We have 90 degrees here, 90 degrees here. We have the same angle here, same angle here. So if this one is 4, can I say also that this one is 4?
Yes.
They have the common
Because it's a right
hypotenuse.
triangle and they have the same.
They have the same hypotenuse. They have the same angles. So also this one is 4. And
they will have the same height.
Yes. Directly I can write that area of ADC will be 4 times 12 over 2. 12 is the AC. And then this one will be 4 times 6, 24, let's say centimeters square. It's okay?
Yes.
And in B, how it will be? What we'll use in B? What do you think?
30, 60, 90?
But we don't know if it is...
Okay, we don't know.
What kind of triangle we have here? We have a right triangle and the height is drawn. And we had a theorem for this kind of triangles?
Equilateral?
No, Euclidean theorem.
Yes.
So if this one is H from Euclidean theorem, how can I write? Let's say this one is A. Now I'm solving B. What is Euclidean theorem? We said that H square is equal to 4 times 9. Yes?
Yes.
4 times 9 is 36. Then H.
So H is 6.
So area of the ABH, what will be?
13 times 6 over 2.
Not 13. ABH on the
Oh, well, 4 times 6. Sorry,
Yes.
I thought for all
4
the
times 6 over
for
2,
big
it will
triangles.
be 12.
So it will be 12 centimeter square. It's okay?
It's okay.
Did we understand?
Yes.
Yes, teacher, it's okay.
Yes, teacher.
Hadi bakalım. We finished one chapter, guys. Now we are starting a new chapter and you will have another book for this. Okay.
Which book, teacher?
Quadratics. You have the quadratics book? I don't have.
Yes.
I don't think that I have here with me. Quadratics book. Do you have it right now with you? Any of you?
I have a teacher, but I
No,
should go downstairs to get it.
Okay, okay, only because also I don't have here the quadratic, or do I have?
Teacher, just a minute.
I have, so okay. Only to check if it starts, if we are starting from the first, yeah, directly with the second page, you have this one, okay. Now, quadratic equations. What does it mean, quadratic equation? Do we know what does it mean, equation? We have an equality, we have some unknowns, and we have one equality. We are equalizing to something. This is equation. Quadratic equation is when we have a second degree term there. We call it quadratic equation. So as you can see, this is the general form of a quadratic equation. Ax squared plus bx plus c is equal to 0, where a cannot be 0, is called the quadratic equation. Why a cannot be 0? Why you think that we are saying that a cannot be 0? What do you think? If a is 0, can we call it quadratic anymore?
I think no.
So if a is 0, 0 times x squared will be 0. And we'll have bx plus c, and there won't be any second degree square term, yes? Because of that, a is 0, because if a is 0, this one won't be a quadratic equation, okay? You can write this definition in your notebook. This is the general form of a quadratic equation, and here in this form, in this equation, a, b, c, they are the coefficients, real number coefficients. They can be any number, minus, one over negative numbers, fractions, decimals, any number it can be, okay? A, b.
Teacher, for example, 2x plus 1 plus 2 is equal to 0 is quadratic.
2x
Right.
plus 1
Plus 2 maybe.
plus 2 is equal to 0. It's not a quadratic equation. X is
Why?
first degree. This one is, but this one is not quadratic. This one is linear equation, first degree.
It should be
This one is second
x
degree.
times 2. Okay.
It has to be x to the power of 2, x squared, okay?
So it can be x to the power of 2 plus 1 plus 2.
Yes.
Okay.
So the coefficients a, b, c can be any real number, and x is the variable, the unknown. X is the x. A quadratic equation written in the form ax squared plus bx plus c is equal to 0 is said to be in standard form. Okay? A quadratic equation is called a second degree equation also. As I said, it has to have a second degree term there, okay? Now, as you can see here, some examples are given about quadratic equation. x squared plus 3x minus 5 is equal to 0 is one quadratic equation. 2x squared minus x minus 1 is equal to 0 is a quadratic equation. Root of 2x squared minus 1 over 2x plus 3 is a quadratic equation. As I said, A, B, C, they have to, they can be any number. Only the important part here, we need to have x squared and in some cases x. In this kind of equations, we call quadratic equation. If we have only x, it's not a quadratic equation, it's a linear equation or first degree equation. Okay? Did we understand what does mean quadratic equation?
Yes. Yes.
Yes, teacher. We must have square.
Yes,
Yeah.
we need to have x squared or y squared or z squared. What is your variable? According to your variable, you will form your quadratic equation.
But teacher, even if there is a root x squared, it can be quadratic or not?
What do you mean root x squared?
For example, root,
Root.
and inside the root is x squared.
In this case, you have x out, so it is not quadratic.
It's linear.
It's linear because you have x, because root of x
Okay.
is x, and then it will be linear, okay?
Okay.
Now, let's see here, what is important for us in the definition? One more time, I'm repeating. Look, the coefficient of x squared, we call it A. The coefficient of x, it's B, and the C is the
This one.
only number part, okay? Not unknown part, only number part. So you need to know which one is A, which one is B, which one is C in your quadratic equation. Why? Because in next lessons, we'll use some formulas and we'll use like A, B, C. And that A, B, C is this A, this B, and this C, okay? Now here we have a table and it's written here the A, B, and C of the equations. Look, if you have this quadratic equation, 3x squared plus 5x minus 9, as you can see, A is the coefficient, the number in front of x squared. So 3 is A. B is the number in front of x, 5, and C is the other part. Look, if it's minus, because the general form, it's this one, plus C, all of them with pluses. So if you have a minus, it means that your coefficient is negative. So C is minus 9, as you can see here. Look in the second one, it's not written in standard form. It doesn't start with x squared first. But also, again, this one is a quadratic equation. So here, A will be, again, the number in front of x squared, which is 3. B is the number in front of x. As you can see, it's minus. There's no any number written, so it means that it is minus 1. And C is the other part, 1. Did we understand?
Yes.
I
But
think
teacher,
yes.
haven't we studied this last year?
I don't know. We didn't study quadratics. We
No.
studied equations, but I don't think
No.
that
But
quadratics.
teacher, like this, to arrange them from the degrees to the smallest degree.
Maybe, yes, in the polynomials, if we studied the polynomials,
Polynomials, yes, polynomials.
to write in standard form from the highest degree to smallest degree, or maybe in Olympiad lessons if you enter to Math Olympiad, I don't know, we have studied. So as you can see in the third one, we have root of 2x squared plus 5x is equal to 0. So the number in front of x squared, root of 2, it's A. The number in front of x is 5, it's B. And we don't have any other number. It means that C is 0, okay? Here in this one, as you can see, we have x squared plus 1 over 2. We don't have x, so it means that B is 0, okay?
Okay.
And this one, Root of 3 plus 1, x squared. As you can see here, we don't have x, we don't have any other number, only x squared we have. So this number,
We can
3
multiply
plus
them.
1, it's a, the others are 0. But this one is still quadratic equation, okay? Because we have x squared. And in the last one, x squared over 2 minus x over 2 plus 1 over 2. So x squared, the a will be 1 over 2 because you have over 2. B is minus 1 over 3. As you can see here, you have over 3. And c is 1 over 4. Okay?
Okay.
Okay.
Now,
Okay, teacher.
in this example, this one, it says determine whether the following equations are quadratic or not. Now let's see together. In A, we have x squared
It is quadratic.
square
So
plus
it
1.
is quadratic.
Because we have x squared, it's quadratic. In B, we have 1 over 2x squared minus root of 2x plus 5.
It is
It
quadratic.
is quadratic.
Because we have again x squared, it is quadratic. In C,
It is quadratic.
it is quadratic only when we will take 5.
Okay, it's not quadratic. 0.
In C, it
It
is.
is quadratic.
It is. It's not problem because it's not
We
equal.
can take it to the other side.
When we'll take it to the other side, it will be equal to 0, and this one is quadratic. What about D?
It is. No, it is.
It is. Who says it is? Who says it is not?
Teacher, I'm confused that because there is minus 1 x to the power.
Yes, we need to think about it because here we have minus 1, this one. It's not x, it's x to the power of minus 1. I will write this equation like x squared minus 2 times 1 over x plus 3 is equal to 0. In this case, if I want to write it in the standard form, I don't want to have this x here. I will multiply by x, and then I will get x cubed minus 2 plus 3.
We don't have quadratic.
So we have
It's not.
square, so this is not a quadratic equation because of this minus 1. What about this one in E? What will happen?
Teacher, we should do it like x times x squared.
So when you will multiply this one by one, you will get,
We will get x squared.
yes, we'll get x squared plus 2x minus x minus 2, and then it will be x squared plus x minus 2 is equal to 0. So as you can see,
So it is.
it is a quadratic
It's quadratic, yeah.
equation. But in F,
It's not, because it will be x to the power of 3.
when I will multiply x with x squared, I will get x cubed. So this one is not a quadratic equation. Okay?
But teacher, we have 2x squared.
Where?
For example, if we multiply
But the
minus
highest degree is x cubed.
each, so x squared must be the highest degree.
Yes. The x squared must be highest degree. Now, let's see what we have next. Solving.
Teacher, please, can you go back just to take a screenshot?
Okay.
Thank you.
Welcome. Here, solving equations of the form ax squared is equal to 0. If you have a quadratic equation that b and c is 0, only a you have. How we'll solve these kind of questions? You know, from solving equations, we know that if we have a times b is equal to 0, we say that a is 0 or b is 0. Yes? If we have multiplication of two numbers, the multiplication of two numbers gives 0, one of them has to be 0, yes? This is the solution of this kind of question. So here I have ax squared is equal to 0. This means that a times x squared is equal to 0. Do you remember in the definition of quadratics, what we said? A cannot be 0, we said.
So x squared.
So x is 0.
Yes, x squared is equal to 0. So from here, x is equal to 0. In this kind of quadratic equations, when you don't have b and c, directly the solution is 0. Okay? So as you can see here, minus 3 over 2x squared is equal to 0 when you have, because minus 3 over 2 cannot be 0. X squared is equal to 0. In this case, we have x is equal to 0. One more thing that I want to tell you about the quadratics, because it is x squared, always you need to have two solutions for x, x1 and x2, okay? So also here you have, but we have one solution 0, but it is for both of them, x1 and x2, okay? We'll show like this, x1 and x2, both of them, they are 0. We have two solutions because it is second degree equation. Always, if you have third degree equation, you need to have 3 solutions. If you have fourth degree equation, you need to have 4 solutions, okay? In second degree, now we'll work with second degree equations. You will have 2 solutions, x1 and x2, and we call them the roots of the x1 and x2 are the solutions of quadratic equation and it will be called roots of the equation, okay? Roots of the equation. Let me check if maybe we'll give in the, no, we have. So x1 and x2 are called roots, okay?
Okay.
So if x1 is equal to x2, like here, like this one, if x1 is equal to x2, this is called double root. Okay?
Okay.
Okay.
Are you writing? I can wait you to write.
Yes, teacher, I'm writing, but I'm finished.
Okay. Now the second type of, did I take the attendance, by the way, for the second lesson?
I think
so.
I think no.
No, yes. Now I remember. So write this second type, like subtitle, and then we'll solve the questions and let me take the attendance. Yusuf is here. Yusuf? No? Anita?
I am here, teacher.
Okay, Alexander?
I'm here.
Okay, Eva?
Yes, teacher, I'm here.
Elza?
Here, teacher.
Okay, Amra?
I'm here.
Okay, Yona?
Here.
Stephanie?
Here.
Kibariye?
Here.
Tringa?
I am here.
Okay. Ardita?
I am here, teacher.
Arta?
I'm here.
Giovanna?
I'm here.
Okay, Bessa? Bessa? Stanislav?
Here, teacher. I'm
here, teacher.
here.
Yeah.
Okay, Salman?
I'm here, teacher.
Okay, Rumeisa?
I'm here.
Sarah?
I'm here.
Okay. Erman?
I'm here, teacher.
Okay. Hamza? Hamza? No? Hamza, no. And Besan?
Here, teacher.
Okay, Besan. Vesa?
Here, teacher.
Okay. Now, guys, the second type of quadratic equations, if C is 0, if we have only A and B, ax squared plus bx. In these kind of questions, do you remember factorizing the polynomials when we had common term? What we were doing?
We were writing x in front and then one.
So the common term here, it's x. In both of them, we have x. So I'm taking x in front of the parentheses, and ax plus b is left is equal to 0. And in the previous one, as I said, if we have multiplication of two terms is 0, one of them has to be 0. So x is 0, or ax plus b is equal to 0. So from here, directly we are finding that x1 is equal to 0. We are finding one of the roots. And in the second one, how we are solving this one? Unknowns in one side, knowns in the other side, and we'll find that the second root. Let me show with the numbers here. As you can see, we have x squared plus x. X is the common. I'm taking in front of the parentheses. What is left?
X plus 1.
Plus 1. So x1 is 0 directly from here, or x plus 1 is 0. From here, when I will take 1 to the other side, I will find that x2 is equal to minus 1. So the roots, the solutions of this quadratic equation is 0 and minus 1. Okay?
Okay.
What about in B? By the way,
X in front.
remind me when the lesson will finish, because I'm taking from your break time.
We have 5 more minutes.
We have 5 more minutes. Okay. Again, we'll take the x in front of the parentheses. What is left inside?
Minus 4x
plus 5.
Plus 5 is equal to 0. So x1 is equal to 0. And from the second one, what we'll get?
0.
Minus
X is equal
4.
to
X is minus 5. So x is minus 5 over minus 4.
Yes.
So the result will be 5 over 4. So x2 is equal to 5 over 4. x1 is 0. x2 is 5 over 4. So from this kind of quadratic equation, you can see that always one root is 0, will be 0. What does it mean?
One solution is 0.
What we mean with these roots? What do you think? What we mean with this one? When I'm finding 0 and, for example, in the first one, minus 1, what I mean? What do you understand?
We find two solutions.
We have two possible answers.
We have two possible answers, and these answers, these numbers that I found here, means that when I will write in the equation instead of x, it will satisfy, yes?
They will give 0 in.
Yes, they will give 0. So when I will write these numbers instead of x, and then I will get 0 here, okay? And the last one, what it will be? I have
X in front.
Okay.
Root of 3x
X minus 2.
minus 2.
Okay, then x1 will be?
X1 will be 0.
Okay.
Root of 3x minus 2.
From here, what we'll get?
Root of 3x will be 2.
To
X
No.
will be
2 over the root of 3.
Root of
Can I leave it like this?
No,
we'll multiply by 3 root of 3 over root of 3. And it will be 2 root of 3 over 3.
Over 3 it will be. So x2 is 2 root 3 over 3. It's okay, guys?
Yes.
Yes, teacher.
Yes, teacher.
Everyone?
That is not harder.
Yes, these ones are not hard.
Yeah.
These two types, they are not hard. But the third type, it won't be hard, but there will be lots of different kind of solutions. But in these two types, we have one way. We don't have any other part of this. You will take x in front. You will find directly that one x is 0 and the other one according to your equation. In the first type, directly we know that will be 0. But in the third type, this one, also this one is not that hard, but when we'll have all of them, like A, B, C, all of them given, we'll have different kind of solutions and different kind of quadratic equations. We will continue next lesson. Okay, I think that we have 1 minute left.
Yes.
Yes, teacher, 1 minute.
Okay, I don't want to start with this one. I hope that we understood the main logic of quadratics, in which kind of questions we call them quadratics, and the coefficients of them. Which one is A, which one is B, which one is C. And this one is important. And the first two types, I think that you understood how we are solving. Okay?
Yes.
So
Yes, teacher.
next lesson.
Goodbye, teacher. See you.
Bye.
Goodbye, teacher. See you.
Bye,
Have a
teacher.
nice
Bye,
day.
teacher.
Have a nice day, teacher.
Thank you. Bye.
Bye, teacher.